Welcome to Understand the Math. In Part A, we are going to state the values of x at which our function f is discontinuous and then explain why. In Part B, at those numbers where our function is discontinuous, we are going to determine whether our function is continuous from the right, from the left, or neither. A function can be discontinuous at a point, but still be continuous at that point from the left or from the right. Let's see how this works. We'll begin with Part A. Let's start by looking at our x values as we go from left to right. Here's the first x value that we're going to look at. If you look up at our graph, notice that our function value has an open circle at that point, and that means our function is discontinuous. So we're going to say that at x is equal to minus 4, f of minus 4 is undefined. And that's why our function is discontinuous. Let's now look at x is equal to minus 2. At this point, our function value exists. However, the limit from the left does not equal the limit from the right. So let's go down here and let's write x is equal to minus 2. The limit as x approaches minus 2 of f of x does not exist. Now let's go to our next point. That's going to be the point 2. At this point, our function value exists, but again, the limit from the left does not equal the limit from the right. So it's discontinuous at that point. We'll write down x is equal to 2. The limit as x approaches 2 of f of x does not exist. Let's now look at our last point. That is x is equal to 4. For this point, our function exists. However, the limit from the left does not equal the limit from the right. So we'll write down x is equal to 4. The limit as x goes to 4 of f of x does not exist. Sometimes you can write does not exist as D and E, and that will make things a little bit quicker. Let's now go to Part B. We'll pull this up so we can see. For Part B, we wanted to know at these numbers, that's minus 4, minus 2, 2, and 4, if f is continuous from the right or from the left or neither. We'll see if we can squish B in right here. So at x is equal to negative 4, we need to look at our function. Because there is an open circle at that point and no closed circle, our function is not continuous from the left or from the right. So we're going to write down neither. Let's look at our next point. X is equal to minus 2. At minus 2, let's go up here and look at our graph. Notice that as we approach from the left, our left-hand limit is equal to our function value. So it is continuous from the left. So let's go down here and let's write left. Now we go to x is equal to 2. Let's go back up to our graph and look at 2. Our function value is defined here. This limit is equal to the function value, so it is continuous from the right. So we'll put right down here. And then our last one, x is equal to 4. Let's go up here and look at our graph and see what's going on at 4. Here's our function value, and the limit that is equal to it is the one coming from the right. So just like x is equal to 2, at x is equal to 4, our function is continuous from the right. I hope this makes this problem clear. I know when I used to teach this problem in class, this was one that students really struggled with and had to go over a couple of times.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.